Okay, our next section is all about combinations. And as you can see, we're going to solve problems including combinations and solve problems by distinguishing between the permutations we just learned about and the combinations that we had worked on in a previous chapter. So let's take a look at what's going to happen. You probably remember a slide that looks similar to this, but remember, combinations are n objects taken r at a time. Where we talk about order does not matter. Okay, in permutations, order matters. So here, the number of combinations, as we already have said previously, can be written again in several different ways. So start looking at your notations. Here's one. Here's the NCR that we used a lot, the parentheses N over R that we've also seen, and then the formula. And this formula looks very similar and looks to me like there's a factorial missing. Probably there, but just the font. N minus R factorial. So the big difference between this one and the permutation is we have that R factorial out front. Okay. Read again as N choose R, but it's a combination, which means order does not matter. So I'm going to take 10 things, and I'm going to take them 3 at a time. And when I do that, 10 factorial, looks like we're missing another one right here. 10 factorial would be 3 factorial times 10 minus 3 factorial. And 10 times 9 times 8 times 7. So we're looking at that 7 factorial on the bottom being the guy that's going to cancel. So we really don't need a ton of them. And 3 times 2 times 1 is what that extra 3 factorial will give us. And do some canceling. You can see I have there the 3 goes into the 9 3 times. The 2 goes into the 8 4 times. What's left? We end up with 120. Remember on your calculator the NCR, the same thing as the NPR. So you have some choices with using technology, or if we say with no calculator, you're going to have to show the algorithm, the formula that we've got here. So let's take into consideration some arrangements, and let's talk about actually what happens when we talk about combinations versus permutations. An arrangement of objects in which order is not important, that cannot be any more clear. Where we said permutations, order matters. So if we say P, N, and PR, order matters. So if we just take a look at these two and talk about what they are with, and I just have Lego blocks here. Okay? So if I say, how many ways can you take these 3 blocks as a whole and arrange them? So start looking at all of them. How many ways can you take these 3 blocks and arrange them in a group of 3? And so you're going to say, well, there's one way. 3 things taken 3 at a time. That's what that combination stands for. 3 blocks taken 3 at a time. How many ways can I do that? Once. I take them all at once. Okay? And again, 3C2, I've got 3 things. How many ways can I take them 2 at a time? 3C1, 3 things taken 1 at a time. Well, that's 3 different things. And then 3 things taken 0 at a time. And the only way I can take them 0 is by doing it one way, which means I'm not going to take any. Okay. But a permutation, if you start looking at this, means we have 3 things taken 3 at a time. But in a permutation, order matters. So if we're going to take all 3 of them and order matters, then let's start making the combinations. If I put the blue one first, I could have the green and the pink. But again, if I have the blue one first, I could have the pink second and then the green. Okay, now that I've exhausted all possibilities there, let's put the green one first. If I put the green one first, then I could have the blue or pink in that order, but still with the green one first, I could do pink, then blue. So right now we're looking at 4 possibilities, but we haven't had the pink guy first yet. So if I make the pink guy first, then I could go blue, then green. Pink guy first, I could go green, then blue. So when you look, there's 1, 2, 3, 4, 5, 6 possibilities of taking 3 things 3 at a time when order matters. Oh, okay, so it does matter. That makes a big difference. So in our combinations, which is what we're talking about right now, order does not matter. There we go. So look at the numbers and you can see distinctly there's really only that one, 3P0, 3C0, that comes out to be the same with one combination. And then the 3C1 and the 3P1 come out the same with 3 possibilities. How many ways can you arrange 3 things taking 1 at a time? How many ways can you arrange 3 things taking 1 at a time? I mean, that's pretty clear. All right, so now let's talk about example problems that would fit. Find the number of ways to rent 5 comedies from a collection of 30 comedies at a video store. So we're going to take 5 of them that came from the original set of 30. So combinations. How many combinations of 30 videos taken are at a time, which would be 5 at a time? So we would use that factorial combination that we learned, n factorial. Yeah. R factorial. So you start putting it into that formula. R factorial is 5 in this case. And then n minus r is 25. And so that's the value we can stop at. That's what's going to cancel. So if we shorten up our work, we'd have 30 times 29 times 28 times 27 times 26, because 25 on down is going to cancel with that 25 factorial there. And then we have that 5 factorial, so 5 times 4 times 3 times 2 times 1 on the bottom, and start looking at what can cancel, and that would have to be your work. Try to go largest value possible. So 5 goes into 5 once, 5 goes into 30 6 times. 4 goes into 4 once, 4 goes into 28 7 times. 3 goes into 3 once, 3 goes into 27 9 times. 2 goes into 2 once, goes into 26 13 times. We've definitely made it smaller, but grab your calculator because now that numerator is fairly large, as you can see. 6 times 29 times 7 times 9 times 13. So there would be 142,506 possibilities of taking 5 comedies from that collection of 30. Okay? Order does not matter. So now, how many ways are there to give 3 honorable mention awards to a group of 8 entrants in a contest? So 3 honorable mention awards, we've got 8 entrants, so taking 3 from 8, combination of 8 things taken 3 at a time, 8C3, do the math. Honorable mention, 56. Whether you use your calculator or whether you use the formula. How many ways are there to to award first prize, second prize, and third prize in a group of 8 entrants? So again, we've got 8 entrants. How many ways can we take those 8 entrants and award first, second, and third prize? So in this case, what are you thinking? Order does matter, because you got a first prize, second prize, third prize. So I don't think we're going to be talking about a combination. We're going to be talking about a permutation. So order matters, and when you do 8P3, you get 336. So look at that combination, and then look at that permutation. Do you see how we say order matters in the second one, where it did not matter in the first one? Okay, Terry's buying paperback books to read while on vacation. How many different ways are there for Terry to purchase 3 novels, 2 nonfiction books, if there are 10 novels and 6 nonfiction books to choose from? Oh, so that's sort of a combination thing. All right, so let's split it up. We have two different things going on. We've got our novels and we've got our nonfiction. So let's do the novels first. And combination of how many different ways? 3 novels, and there were 10 total. So how can I take combinations of 3 from the original 10? How can I take combinations of 2 from the original 6? And then I think we're going to have to multiply them together because it's n ways to do this, m ways to do this. M times n would be our total. So with your calculator, you can multiply that out, or you can use the formula if it's a non-calculator. But take a look. We would have 1,800 possible combinations of this. And lastly, let's look at our lunch combination. Recent survey, 30 students, 25 of them favored an early opening time for the cafeteria, 5 opposed it. Find the probability that a random sample of 8 respondents from this survey, exactly 6 favored the earlier opening time and exactly 2 opposed it. So when you start working on this one, you got to start thinking, wait a minute, earlier time, for it, against it. You have to think of all those combinations. So look at your setup. Try this one. What is your setup? And I did put a hint or a reminder up about, remember, probability is based on the number of outcomes in the event A over the number of outcomes in the sample space. So our question is that last one, find the probability that in a random sample of 8 respondents, exactly 6 favored the earlier opening time and exactly 2 opposed it. What's your thinking? What's your setup? We got combinations coming from the bigger set, and then we have our probability question from our smaller sample set. Check yours. Were you thinking taking 25 of the favored and choosing 6 people from that? Then taking 2 from the group of 5, and we have to divide that over the total, which was 8 respondents from that survey were taken from the set of original 30. So what is your total sample space? All right, so with that, you're seeing a couple different combinations or ways to write combinations depending upon the situation. They're definitely getting a little more complicated, but the more we practice the different combinations, the better we will become. So combinations versus permutations. You should have a good idea of how those work now.